Okay, so the topic for this video is going to be about proving that triangles are similar. So our central question here, thing we're going to be trying to answer by the end of this video is, how are triangles proven to be similar? Now, if you watched the last video, we were talking about similar figures and what it meant to be similar. And so what this says up at the top is that Euclid, our father of geometry that proved all this long ago, had become intent on discovering different ways of proving that two triangles were similar. And he discovered 3 different methods of proving triangles similar. And we're going to take a look at those 3 different methods. So our first one is called AA, the AA postulate. And what that stands for is that if 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar. So what that would look like would be something like this. If we have this triangle over here, and then this triangle over here, and if we just know that these 2 angles are congruent, and these 2 angles are congruent, then we could say that those triangles are similar. So we could write that out maybe if we name this triangle ABC, this one DEF. We could say that triangle ABC is similar to triangle DEF by AA. Right, that would be what we would expect to see if we were using AA. Our next method is SSS. And we've seen this before with congruency, but this is SSS similarity. And what that says is that if the measures of 3 sides of one triangle are proportional to the 3 corresponding sides of another triangle, then the triangles are similar. Okay, so this one's looking at the sides. And remember, we're not expecting the sides to be congruent. We're expecting them to be proportional. So that might look like this. So maybe if we've got something like this, if the sides are 2, 3, and 4, and then the sides over here are 4, 6, and 8, right? We can see that all the sides are being doubled. So all the sides are proportional. So in that case, we could say triangle ABC is similar to triangle DEF by SSS. Right, and specifically we see 2 times 2 is 4, 3 times 2 is 6, 4 times 2 is 8, right? So that's what it means to be proportional. And then our last method is going to be SAS. And this one is if the measures of 2 sides of a triangle are proportional to the measures of 2 corresponding sides of another triangle, and the included angles are congruent, then the triangles are similar. So this one's going to look like this. So maybe we know that this side is 2 and this side is 3. This side is 6, this side is 9. And we've got these included angles being congruent. So if we've got ABC over here, DEF over here, then we can see that this times 3 is this times 3 is this. So those sides are proportional, and we've got those included angles being congruent. That would let us say triangle ABC is similar to triangle DEF by SAS. Okay, so those are going to be our 3 different ways of proving that triangles are similar. And of course, this is quicker than what we saw in the last video, because the last video we were trying to check if things were similar by checking everything. We had to see if all the angles were congruent and all the sides are proportional. These are shortcuts for verifying if things are similar, much to our shortcuts for proving that triangles were congruent that we saw a few videos ago. So what we're going to be looking at on these 2 problems is determining if the triangles are similar. And if they are, we want to complete the similarity statement and determine the method of triangle similarity used. So looking at this first example here, I can see that I don't have all the sides, so I'm not going to be checking for side, side, side. Instead, let's check how this side relates to this side, and this side relates to this side. So 12 over 16, checking these yellow sides. Let's see if that ratio reduces down to something cool. 12 over 16, that would be 3 over 4. Checking my green sides, I would do 15 over 20. That too reduces down to 3 over 4. So I've got 2 sets of proportional sides. I don't have 3 though. So do I have an angle? Yeah, I do, right? These vertical angles, they have to be congruent. So since I've got the sides being proportional and the included angles being congruent, then yeah, these triangles are going to be similar by side, angle, side. So now let's see about that similarity statement. If I do A, B, C, right, if I follow the way that this is working, I go down the blank side, then the green side. So blank side, green side would tell me I need to do EDC. That would be the way of lining those up. Now this one, I don't have any angles, so this has to be side, side, side if it's going to be anything. But let's check to make sure that these sides are actually proportional. Now this thing's been spun around. Let's be careful about this. The smallest side on ABC is 54. That needs to go with the smallest side over here, 36. So 54 over 36 with the yellow sides here, both divisible by 9. That would be 6 over 6. Oh, I can do better than that, can't I? 18? Yeah. Both divisible by 18, I could do 3 over 2. Okay, now let's move to the next smallest sides, 60 with 40. 60 over 40, both divisible by 20, that would be 3 over 2. Okay, we're looking good. So far we got the same thing. And then 72 over 48, that's both divisible by 24. So with the blue sides, I get 3 over 2 as well. So I got the same thing for everything, so that does verify that they're similar by side, side, side. And congruency statement-wise, A, B, C, that is green, yellow. So I need to do green, yellow. So that would be D, E, F. Okay, let's keep it cruising. Let's open that up, check out the inside. Okay, so same kind of idea here. Determine if the triangles are similar. If they are, complete the similarity statement and determine the method of triangle similarity used. Okay, so this one, I've got no sides. But I do have, oh, check that out. I've got some parallel lines. Now, it might be easier to imagine these if we extend them a little bit. But if I'm looking at those lines being parallel with this transversal here, don't I know some angle pairs, right? We had a lot of videos about angle pairs being formed by parallel lines. What I'm thinking about are these corresponding angles there. Those corresponding angles have to be congruent since those lines are parallel. So that's one set of angles that I know are congruent. And then likewise, if I imagine this is my transversal, I got these corresponding angles. So I do have 2 pairs of congruent angles, which means that these triangles have to be similar by AA. Now, some of you might be wondering, what am I even talking about, these 2 triangles? I'm talking about triangle ABC, the very big triangle, and then I'm talking about triangle ADE, the small triangle. They have those 2 sets of angles that have to be congruent, so those triangles have to be similar by AA. And now I've got another one with a bunch of sets of sides. So I'm thinking about side, 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 but we got to make sure. So let's take small side over here, small side over here. Small with small, 39 over 60. Both of those are divisible by 3. That would be 13 over 20. Now let's move up to the next biggest sides. We got a 50 and an 80. 50 over 80. With the green sides here. Both divisible by 10. That's 5 over 8. I already got something different, so this is not going to be similar, but let's double check this last one here. 65 over 100. That's both divisible by 5 at least. That's 13 over 20. So we got 2 that are the same. 2 of them both went down to 13 over 20, but that 50 over 80 did not. And we need all 3 if we're going to use side, side, side. And we didn't have them, so we'll just say not similar here. We don't need to complete the similarity statement because they're not similar. Okay, so let's try a few proofs out now that we know how to do this stuff. So proving triangle similar. To prove 2 triangles similar, first use the diagram and the given to establish congruencies and equal proportions. Then determine the method of triangle similarity to use. So let's see what we got going on here. Our given says that AD is similar. I'm sorry, it's not similar. It's parallel to BC. I got similarity on the brain. That is a given. And we're trying to prove that triangle ABC is similar to EDC. Well, if these lines are parallel, put some arrows on them to mark them. And we don't know anything about the sides here. Nothing about the sides. So I'm not thinking about side angle side or side side side. I'm just thinking about angle angle. And in order to use angle angle, we got to get 2 pairs of congruent angles. Now one jumps out to me right away. The vertical angles, right? We use vertical angles all the time when we were trying to prove triangles congruent. We can use vertical angles when we're trying to prove triangles are similar. So I'm going to go ahead and say that angle ACB is congruent to angle ECD by the vertical angle theorem. That is one set of congruent angles. We need another set of congruent angles if we're going to get away with using AA. So what's another set? Well, we haven't used those parallel lines yet. And we know that if lines are parallel, and we imagine them kind of being extended a little bit, and they're being crossed by a transversal, we've got angle pairs, right? Anytime we got parallel lines, we got special angle pairs we can use. And I'm thinking specifically about angle A and angle E here. Angle A has to be congruent to angle E because they are alternate interior angles. And that's the alternate interior angle theorem. And now checking out my diagram, I've got 2 sets of congruent angles. And that means that triangle ABC must be similar to triangle EDC by AA. So AA is probably the easiest way of proving triangles similar if you can manage it. But sometimes we're not going to be able to find 2 angles, and then we'll have to use some sides or something. But in that case, we didn't know anything about the sides, so angle all the way. All right, let's check out the other side. Then we got 2 more we're going to try. So this one, what do we got in the given here? Oh, we got some sides being proportional. So our given here says that AD over AB is equal to AE over AC. Okay, so that's essentially saying, so let me mess with my highlighting a little bit here. It's saying AD over AB, so that's saying this over this is equal to this over this. Okay, so that's two sets of sides being proportional. Now, we don't know anything about DE or BC, so we can't do side, 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 but what I hope you guys see is that both of these triangles, both the top one and the big one, it's kind of tricky to spot for the first time, but both of those triangles have angle A, right? Notice they both have an A in their name. They share angle A up at the top. So this is a weird case of me being able to do angle A congruent to angle A reflexive property. Most of the time we've used reflexive property in the past, it's because they share a side, but you can use reflexive angles as well. They're just a little bit more rare. But they both share angle A up there. That's going to give me the included angle between the green and the blue sides. And that's going to be enough to say that triangle ADE is similar to triangle ABC by side, angle, side. Right, I got those two sets of proportional sides from the given, and then I get that included angle to let me do side, angle, side. All right, and our last one here. What do we have here? We've got AD parallel to BC. ADBC. Oh, that's supposed to be AB. And, whoa, what's going on here? That should be AB parallel to CD. That's what that should say. Now, your version will already have that correct. I'm just using an old copy. Sorry. Let me fix that on my given. So that's AB parallel to CD. And then we also have BC parallel to DE. That's these ones. Okay. Crisis averted. Of course, your version should already have the good stuff on there, but we've got our parallel lines. Now, we don't have any sides being proportional already, so my mind's immediately thinking, hey, I got no information about the sides. I should be thinking about trying to use AA. What do we need to do here? Well, if we've got parallel lines, every time we got parallel lines, I'm thinking about angle pairs. So if I've got those two yellow lines being parallel, being crossed by this transversal, then I'm seeing angle A being congruent to angle C. Angle A must be congruent to angle, well, there's more than one angle C, so let's name that one by 3 letters, DCE. Angle A is congruent to angle DCE because those are corresponding angles. And that's the corresponding angle postulate. So we got one set of congruent angles. Once again, you should automatically be thinking about angle pairs if you see parallel lines in the given. Now the other given said another set of parallel lines, right? We know blue line here is parallel to blue line. So if I'm looking at the blue with the green line's being crossed by the green transversal, then I actually see another set of corresponding angles. That's angle BCA being congruent to angle E because of the corresponding angle postulate. So now I've got my two sets of congruent angles, and that's going to let me say that triangle ABC is similar to triangle CDE by AA. once again, we matched up the letters there, and we got ourselves to some angle there. Right on. So your time to shine. You've got two that you're going to take a look at and try to determine why they are similar, or if they are. And then you've got one proof that you're going to try here, trying to show me why those are going to be similar step by step by step. Okay, so give those a shot and then come back to the video when you are ready to check. All right, so this first one here, if I've got those vertical, I got some vertical angles in there, those would count. And then I've also got some alternate interior angles that I could get from those lines being parallel. So I'll say triangle ABC is similar to triangle EDC by AA. Now this one, what are we thinking here? Well, let's pair some stuff up. This side on the small triangle would go with this side on the big one. So that would be 10 over 25, which reduces down to 2 over 5. Then 12 to 30 divided by 6 would be 2 over 5. And then 8 with 20 divided by 4 would be 2 over 5. So I'm going to say triangle ABC is similar to triangle ADE by side, side, side. Now, if you wanted to be fancy on that one, you could have noticed that both of them use angle A, so you could have actually done it with side angle side as well. All right, and then our proof here, we've got DE parallel to BC. And we're trying to prove that these triangles are similar. So a couple different ways you could have spotted angle A up top. They share angle A, so you could have done the reflexive property. And then maybe these two angles, since they're corresponding angles, would be angle ADE congruent to angle ABC by the corresponding angle postulate. And that's going to let me say triangle ADE is similar to triangle ABC by AA. Now, you had some options on that one. We used angle A in those two, but you could have also used angle C with angle AED. That would have worked as well for a different set. Those would have been corresponding angles. So if you use those, your reason should have been corresponding angle postulate. All right, hope that went well for you guys, and that wraps up this video.